Welcome back to PV Online. Today we're going to talk about impulse. But in order to do that, we really need to revisit momentum. And remember, all momentum is inertia in motion or mass in motion. So an object in motion is going to have momentum. And remember that momentum was simply mass times velocity. Momentum is a vector, which means direction counts. So the direction that the object is moving will affect the outcome. When Newton derived his second law, he really wasn't talking in terms of acceleration of an object. He was looking, in fact, at the momentum of the object. And what he noticed was is that if you gave an object an impulse, its velocity would change or its momentum would change. So in this case, if the velocity changes, we know that momentum is going to change and that we're going to accelerate. We know for an acceleration to occur, we have to have an unbalanced force. If a force is applied over a longer time, more acceleration occurs. That's why when you're playing baseball or softball, your coach will always say swing through. By swinging through, you're elongating the time that the bat is in contact with the ball, making the ball accelerate more. So a force applied over time will change the momentum of the object. This statement is going to be restated over and over again. So it's going to be really important that you realize that. You apply a force over a period of time, the momentum will change. So let's take a look at a few examples. On the left, we have our boxer. And our boxer is moving back as the punch approaches. And as it does that, the time that the glove is in contact with his face is longer, making the force smaller. You compare that to the right side, and if the boxer was leaning into the punch, then the time is going to be much smaller. The force is going to be very large. So we're going to have a small force applied versus a large force applied. And that's why if you've ever watched a boxing match, if the guy's leaning into it, chances are he might get knocked out. All right, we have a baseball player. If you follow through, we're elongating the time. All of a sudden the time gets bigger. We're applying that force over it. That's going to make the acceleration of that baseball much larger. So let's revisit Newton's third law. We know that for every action, there's an equal and opposite reaction. So we have a large truck and a smaller red truck that's going to approach each other, and they're going to collide. And according to Newton's third law, the force experienced by the big truck equals the force experienced by the small truck. Now, since they're in contact for the same length of time, that means also their impulses will be equal to each other. So the impulse experienced by the large truck will equal the impulse experienced by the small truck. Since impulse equals the change in momentum, that simply means that the change in momentum of the big truck is going to equal the change in momentum of the small truck. Now this is where it starts getting different. Because the mass of the truck is so big, that means its velocity change is going to be smaller. Compare that to the small truck. The mass of the truck is small, meaning that its change in velocity has to be much bigger. So now the change in momentum is going to be the same, but do you see how the change in velocity is different? And that's going to affect the acceleration. Since the mass of the big truck is so large, that means it's going to undergo a much smaller acceleration. And when it undergoes that smaller acceleration, it's going to have less damage. Compare that to the smaller truck. Its mass is small, which means the acceleration it undergoes is going to be much larger, and therefore the smaller truck is going to have a lot more damage. All right, so we have an example of increasing momentum. We're going to hit a golf ball. We're going to hit a golf ball. The initial velocity of the ball was 0, and you're going to apply a force with the club over a period of time, causing the ball to accelerate and move a lot faster. The baseball and the bat. You supply an impulse. The bat decelerates the ball and accelerates it in the opposite direction very quickly. So we have this example, and in this case, the truck is going to run into a stack of hay, and in doing so, it's going to apply a small force over a longer time. Compare that to the truck hitting a wall. When it hits the wall, the time it takes to come to a stop is going to be very short, very brief, meaning that the force that's going to be acting on it is going to be very large. We can also change the momentum over a short period of time. But in doing so, if we do it over a short period of time, the force acting on you is going to be much larger. When we look at an airbag, the whole point of an airbag is to make the time much larger and bringing you to a stop, therefore making the force acting on you smaller and with any luck, causing less harm. All right, we've taken a look at impulse. We'll see you next time.